Part 5, Options and Applications. There are more types of innovative wall products than you can shake a stick at. While the most common sheathing type is oriented strand board, there are a variety of other options as well, each with their strengths and weaknesses. The most common type of core material is expanded polystyrene, but as we'll see, there are plenty of other options as well. The method of connecting panels together also differs greatly from manufacturer to manufacturer. ACME's products are typically made with OSB facing and expanded polystyrene cores, but as we'll see, other options are also available.
What's called neopore material. It's a proprietary foam that's made by BASF, or foam bead, and it has graphite impregnated into the bead itself. So it gives a higher R value for the same thickness of material.
Oh, yeah, cool. Yeah.
That's the difference between the two.
Okay.
So this is the typical 1 pound density EPS foam, just white beads, and this is the 1 pound density. Actually, it's a little heavier than that, but 1 pound density neopore foam, which so inch per inch, this is an R4 per inch, this is about an R5 per inch. So
cool.
In the end, you know, you're gaining a little bit as far as R value is concerned. Yeah.
And do you throw that stuff in the densifier too?
No, unfortunately, we can't do that because it brings the temperature up some. And
oh,
so
geez,
the densifier won't melt it the same as it would the normal bead foam.
Interesting. So. And are you doing anything other than OSB? I know you were also doing
the magnesium oxide board. Structurally, the panels are what we would call curtain wall panels, so they don't actually have any structural integrity. They can be incorporated into a structural system, whether it's double, dimensional 2x at the seams of each panel, and then it's almost like you're building these panels around either a timber frame or some other steel structure or inset lumber that is the structural kind of skeleton, and then the panel just encases it. The material itself is a cement type board, so it's a lot like the hardy board material. It has a lot of great attributes. It's fire resistant, mildew resistant, water resistant, doesn't absorb any water. But because it's a poured material, it is reinforced. It has fiberglass reinforcing in it, but because it's poured, the quality control is always in question. There's some, you can have pockets of air, or something just doesn't pour quite right, and structural integrity becomes a bit of a question. So up until this point, we haven't treated it as a structural material, structural panel, so on its own.
And
we usually get maybe 1 to 2 projects a year. With
okay. So. And I know it's possible, but I don't know if you guys do it, to put straight drywall on one side for a non-structural panel.
Yeah, I mean, we can laminate pretty much anything to the foam.
Okay.
Again, non-structural, but for years people were using, again, what most companies call them curtain wall panels, so they have drywall on the interior and OSB on the exterior, and usually for some kind of a frame enclosure, timber frame or steel structure enclosure. So
imagine that'd be kind of fussy to transport.
It is. It gets damaged easily. Yeah. The same with the MGO board. It's the type of thing, if you think about your panel seams being the same as your drywall seams, if there's any movement in the building, shrinkage, racking, anything, those seams are going to crack. And so then you have to go back and tape all those seams again and clean everything up. So there's, there could be some ongoing maintenance issues with it. So
cool. Yep. Someday mushrooms?
Somebody has tried and did not succeed.
Oh wait, you did try?
Oh, we didn't, but there was a company out of New York that was trying to use it.
They're
trying to make the panel itself, the foam core, out of a mushroom. And haven't heard much. They also used there were some manufacturers that were using straw to make a cord.
Those things are so heavy.
And that's the problem with the mushrooms.
Oh,
Same
is it?
idea.
Okay.
It was exceedingly heavy.
Well, they're both more likely to rot too, right?
Yeah, there's no, you're introducing a cellulose type product into the structure. So
Yeah.
where the foam, we don't have to worry about that with the foam, with the EPS. The OSB, you want to treat it just like you would a normal stick frame home. You want to keep dry, as much as possible.
Mm-hmm.
But the nice thing about the foam is that it's not going to rot by any means.
What about insects?
Not any more than your typical house. I mean, there's no nutritional value in the foam itself. So if you get carpenter ants or anything else in the house or into the panels, they're making nests in it just because it's easy to move through. Mm-hmm. So you want to treat the house again similar to a stick frame house. You want to pay attention to treating around your property. Best bet when you excavate is to treat the soil first before you start pouring your foundations. Just make sure you try to get rid of any of those ground nests out of the area. Okay. A lot of people don't think about it. They just dig and and then they have all kinds of problems to start off in their house, brand new home, and they have insects running everywhere. It's various treatments that can be used for it.
Yeah, we can treat the panels too. Needed.
Okay.
For both the foam and the OSB.
Yeah.
Okay. Well, good to know.
Yeah.
Nice. Now let's take a look at a local project that was built from ACME panels. This is a small second-story apartment above a garage. It was built for me by Taylor Hollow Construction, the sister company to ACME Panel. And I'm going to show you some time lapse so that you can see how it was constructed. The bottom half of the building was built in 2009 using insulated concrete forms. It's a 2-bay garage with space for a shop. And I built the building in parts because I wanted to use innovative building systems, and I didn't have enough money to do the whole project at once. So I figured why not do it in pieces so that I could get the end product that I wanted and try out different green building products along the way. So as you can see, a large part of the first day was spent getting the basic, the floor of the second story or the roof of the garage set up so that it could be used for panel construction the next day. And you can see 2 holes in that slab, one of which is a block out for a future elevator shaft, and the other of which is for a stairwell. And this building was originally designed, or at least the second floor apartment was designed, to be a home for my aging parents. So it's affectionately referred to as the granny flat. And that elevator blockout was part of the design, again, to allow for future installation of an elevator, even though I didn't have the budget to start with. And it became a key element to work around, and also a bit of a safety hazard while these folks were setting up the building. You can see that they've got the first corner set up, and we're nearing the end of the first day. On the second day, they had to go ahead and remove the tarps that were blocking the openings, and now they're proceeding with installing and building out the second wall there at a right angle to the first wall. And what you will see when this building is ultimately complete, I'll show you a picture of the area right there in the center of the building closest to the camera. I installed a whole wall of windows that can be opened up onto a giant back porch. So during this phase of construction, those were not installed. Those were not in the budget for this particular year. And so you'll see that these guys leave that space open so that those doors can be installed in the future. You'll also notice that they are building a wing along that wall to support the roof, but the area of the elevator shaft and the stairwell are not within the conditioned envelope of the building. So the area outside there was built with stick framing since it was not meant to be conditioned space, and that actually saves some money on the project. That's why that wall on the left-hand side of the screen is set back from the edge of the building. You can see now that they're working on the front part of the building. They put in piece by piece and then infill over window headers. There's the peak of the structure, and there are parallam beams used to support the roof structure. Now we're on day 3, and they're finishing setting the panels for the walls, as well as the bond beams along top and setting all the dimensional lumber in the window and door openings so that those can be put in at a later date. So you can see this wall has really gone up quite quickly. In about 2.5 days, the walls of the building are erected. And again, there's that gap along the wall, the back wall of the building, which is facing the camera, which is where the giant doors will go, the 8-foot window wall that opens up onto the back porch. So here they're just putting in the final connections along the top of the SIP structure. And there we have the walls pretty much complete. Now here we are on the 4th day of construction, and you'll see what they're doing is constructing a center structural support wall that will support the parallam beams that go into those pockets you can see in the wall furthest away from the camera. So there are beams at the midpoint of each of the roof spans, and ultimately this building has a cathedral ceiling, so it's entirely conditioned space inside that envelope, which is one of the biggest benefits of SIPs, is that you're able to recover a lot of usable space within the building. So this is basically a 3-room apartment. There goes one of the parallam beams that's supporting the loads of the building and transferring it. Right below where they're working are 2 garage doors, and so the loads from the roof have to be transferred over to the sides of the building where they can be borne without bringing down the garage door openings. But that area where they're working now up above those beams, on the back side will be a small attic storage area within the conditioned space, part of it anyway, along the center. To the left in the rear is the bathroom, and to the right is a bedroom. And then the area with the large doors is a giant open kitchen and living room space. And that's the end of the 4th day, and now they're ready for roofing. Now, to my eternal dismay, I had to travel out of town the day the roof panels were being set, and so I do not have photographs of that process. But what I can show you is some shots of the beams that were later installed. Here's the opening and the porch after it was constructed from the inside and the outside. Here are the windows and the big doors going in. Here's a view from the inside of the living room out onto the porch. And here's the screens that have been put to enclose the porch. And last but not least, here's a shot of the building itself. So with that, thank you so much for your attention to this presentation. And it's time for any last questions we have for our hosts.